So, in this panel, we're going to be discussing how would you pronounce it? Is it LoRa? Was it LoRa? LoRa, that was it.
LoRa in most of the world.
Yeah,
except a lot of people in the UK tend to go for the LoRa.
Yeah.
Because it comes from long range. So LoRa doesn't.
Maybe.
But it's LoRa. Everywhere I go, it's LoRa.
Fantastic. Right. So to kickstart off this, we're just going to go through some sort of basic questions about what the technology is, how it's used, and what applications we find it in. And then we'll be moving on to sort of the latest advancements in that field. So I think the first thing I'd like to ask, and I think it's probably one of the most important questions, is what makes LoRa different to other radio technologies? You know, things like Wi-Fi, Bluetooth, cellular.
Okay. I guess just to check anyone, if they don't know who Semtech is, and you've heard of LoRa, Semtech is basically the IP owner of LoRa, and so we're sort of behind the technology, and we created we're one of the initiators of the LoRa Alliance. So Semtech and LoRa is kind of synonymous. So what's different about the technology is it's built from the ground up for IoT sensors. It's not built for streaming data. It's built for sleepy devices that basically wake up, go ping, and go back to sleep. It's not built for kilobytes of data every day, megabytes of data every day. It's built for bytes. It's not completely constrained to just a few bytes a packet. You know, you've got quite a range, but it's not built for anything streaming. It's also very uplink centric. The idea is that most devices assume they're connected. They spend zero power searching for the network. They never try and work out what's their local gateway because the device is actually connected to the server in the cloud, and they don't care how the signal gets there. At some point, they might say, I'm in an alarm situation. I want to send a confirmed uplink. So I'll send a letter, I'll set a flag, and I wait for the network to say, yep, got it. But essentially, apart from you're banging in, can you turn it down a little bit? Or you're a little bit weak, can you turn it up a little bit? Pretty much the network is quiet to the device, and the device just does its thing, wakes up, takes a measurement, spits it out. So it's completely different to Wi-Fi, Bluetooth, where you have a point-to-point connection, you negotiate a link, you jump from one channel to another, all of those kinds of things. Mobility is created through the fact that you don't care what gateway, you just, as you move around, you just keep spitting out the packets. Whatever gateway is around, picks it up.
So it's sort of a bit like, I'm just trying to think of an example, sort of like an analogy, maybe something like a foghorn in the middle of the sea, you blow it, you don't know if anyone's going to hear it, but if it does get somewhere, it's got somewhere and someone's received it. But you're just interested in just sending your message out in the first place with very little care about whether it gets there, unless, like you say, you want to make sure it got there. In which case, that's when the confirm system comes in.
Yes, it's a little bit, just think about a choir, right? You've got microphones all around the stage.
Yeah.
Those are our gateways. They all come to a mixing desk, that's our server. So you hear the same voice through multiple microphones, they all come to the mixing desk, and you can pick one, you can pick them all. It's pretty much the same thing.
That's quite a good analogy, actually, Richard, because if you have lots of people in a choir and they're all singing, it's quite easy for somebody who's maybe not near a microphone not to be heard at all. And that's possibly one of the technology challenges that LoRa has. But going back to the applications that LoRa has, I work at Renesas. We're a semiconductor manufacturer. Like Semtech, we don't make Semtech transceivers, obviously, because that's Semtech's IP. But in my role, I'm kind of connectivity technology agnostic to a certain extent. My job is to help our customers come up with solutions that work using Renesas microcontrollers and other technology. So we've used LoRa in a number of technology demonstrators, most notably in a smart agriculture demonstrator with one of our ultra-low microcontrollers. This is actually a batteryless application. It uses energy harvesting from a thermoelectric generator and solar and wind, the combination of all three, to generate the energy, not just for the sensing and data acquisition, but the LoRa communications as well. I think that's the kind of application where LoRa excels, where you've got very, very little energy available, and you have long distances, outdoor, little interference, and not much in the way of other infrastructure you can use to piggyback on for your messaging. So smart agriculture is definitely, I would say, one of the top applications that Semtech and LoRa have been successful in. Would you agree with that?
Yeah, sure, and it's fantastically efficient. So you can just say, I haven't harvested enough energy yet. So we have applications where you've got clip-on energy for AC circuits. So you put it onto an AC circuit, but the heating has been off all night, and the sensor can go to sleep because there's not enough current going through the wire for it to harvest enough energy to transmit. Then as soon as you get current, it harvests enough energy, and bang, it comes back online. So as long as you know that behavior exists, it's great. So you've got no battery life considerations ever, because it harvests what it needs to transmit when it needs to.
So would it be fair to say that LoRa is one of those technologies that you might find used in applications that don't have reliable or large power sources? Like, for example, something like Wi-Fi or cellular. You can stream data. It's great for IoT and stuff, but generally speaking, it's very power hungry. And so what you're saying is that LoRa might be useful for something which uses energy harvesters because it only needs to send a message once in a blue moon, sort of thing. Would that be right?
Yes, that's true. Let's not forget, though, that there's some very, very low power modes in those other technologies.
Yes.
They're just not necessarily built from the ground up to do that. A Ring doorbell can last on its battery on your Wi-Fi for some months, but a LoRa equivalent might last for 15 years.
Yeah, I suppose in the case of Wi-Fi, like, it has to re-establish a connection, confirm the password, exchange keys. Once it's finally gotten there,
right,
then it does other things.
Whereas your LoRa device can be asleep for a year and just go ping.
Yeah.
Actually, can I just say a word about Wi-Fi being high power? Because Renesas recently acquired Dialog Semiconductor, and it would be remiss of me not to mention their ultra-low power Wi-Fi technology, which Richard alluded to. And it may have been in the past that Wi-Fi was not a viable technology for battery-operated equipment, like smart locks or doorbells, but our technology is way ahead of what anyone else offers. And it actually is an example of how technologies at the moment that LoRa is competing with, like cellular, which are at the moment much too high power for many of the applications, are actually making massive progress on that front. And just because they're not viable right now doesn't mean that they won't be in the near future.
I got a question about LoRa, actually. We were discussing about this earlier, and I think you're saying that the operating frequency is about 843 megahertz. Is it? What is it again?
It depends on where you are in the world, but we call it sub-gig ISM. So typically, here it's about 868 meg.
868. And so my question really, in terms of the energy usage, comes down to how does it compare to things like ultra wideband? Because I know that one's also another contender for very low energy, and in terms of range, it's sort of. It's not going to be because I think LoRa is like 15 miles, isn't it, as you were demonstrating earlier? But
yeah, ultra wideband is kind of a buzz at the moment, and we do have ultra wideband technology, but we don't see it as being an alternative or competitor to a low power wide area network. It's really for location services in quite restricted areas. So it's also
right.
A lot higher power, so not really compatible.
So to a first approximation, one can, if you're trying to get distance from a radio signal and you're looking for time of flight, then pretty much bandwidth, the inverse of bandwidth is the accuracy at which you can timestamp.
Yes.
So the wider the bandwidth of the signal, the better you can timestamp. So if you to take LoRa, it's really quite difficult to timestamp, and we can get timestamps that are in the order of tens of nanoseconds.
Yeah.
But ultra wideband, you can bring it right down, so you can get those kind of centimeter type, which you could never get with something that's low bandwidth like LoRa, and that's literally physics.
Yeah.
you've got a a megahertz or so coming down from a GPS, so you get sort of 1 nanosecond-ish, which relates to centimeter, like 30 centimeters at the limit.
So what would you say is the biggest challenge that LoRa faces in terms of implementation? I mean, what would you say are the biggest physical challenges that you face?
So I can speak from a lot of experience on that one, and you'll probably back me up, I'm sure. It's, sometimes we should agree and sometimes we should disagree. But essentially, we've made it hard by being open, because the openness of LoRa does not define any business model. Essentially, the LoRaWAN standard with the LoRa Alliance means anyone can make a device, a gateway, a dashboard, a network server, or whatever.
But hold up, it's proprietary though.
Not as of this week, it's ITU standard as of this week, so it's not proprietary.
So if someone, so it's just to confirm, so if someone wants to design their own LoRa system from scratch, there'd be no royalties or license fees?
Absolutely no. It's an open standard anyone can design to. But that, in some ways, is the complexity we bring, because now there's 500 companies at least in the LoRa Alliance all doing their thing, and you've got this, what I call the maze of complexity. You start Googling something and you get hit with so much that is essentially the hardest thing about LoRa, is deciding what to do about the different bits. And maybe you've got some experience to offer on that too.
Yeah, I mean, it's no coincidence that smart agriculture is one of the areas where LoRa's been successful, because there's no problem with land ownership. Farmer owns the land, he can put his gateways anywhere he likes. LoRa requires gateways, and if you're in an urban environment, where do you put them? You have to lease a site from somebody, you have to maintain that land, secure it, have utilities supplied to it. I mean, that is a big challenge, one that shouldn't be underestimated. So whereas LoRa's been successful with quite moderate rollouts, where it's a big rollout, unless that person who's setting up the LoRa network actually has access to that kind of infrastructure, then it's a real challenge to maintain that. I think we've seen customers, and actually we've seen Sigfox. Sigfox is perhaps Semtech's historically number one competitor, and Sigfox was different to LoRa in that it provided the network, but it tried to do deals with cell phone companies to site their gateways in cellular base stations, and because they weren't able to give the cell phone companies enough money, the cell phone companies stopped being interested in it, because it's quite a hassle to maintain these sort of facilities. And of course, LoRa doesn't have that network issue, but it still has the fundamental issue of having to gain access to infrastructure and gateways.
So just going back quickly, so you're saying that it's now an open standard, so anyone can basically work on the
It's an ITU standard,
right,
as of this week.
And out of curiosity, because I'm not quite sure in terms of frequency bands, is 868 was it? Sorry, megahertz. Is that an open, like 2.4 gigahertz? Is that an open frequency?
It's unlicensed. So 868 in Europe, but so there's the sub-gigahertz ISM has different bands in different regions. They sort of go 915 or so in the US, and there's different frequencies around the world.
So for example, in the UK, the 868 band is unlicensed.
Yeah, it's what we use for the garage door openers and things like that.
Which is quite interesting, because you've gone from a proprietary system, which you could have taken royalties off, and now you've made it an open standard where on a completely unlicensed band. So in terms of development, how do you see your company as trying to sort of essentially profit from it? I mean, what would be your business model on that? Because if it's open, I imagine it becomes more difficult.
Semtech's a silicon company. We sell silicon. That's pretty much it. So, we have a small cloud services division, which is to support the modem services on our devices, so that we've got this device to cloud concept where you can literally have an end device which is fully managed. So we provide a service, an optional service. So the business model of Semtech is literally to sell silicon, and the IP of the LoRaWAN standard is owned fully by the LoRa Alliance, which is owned by its members. So Semtech is a board member on the alliance, of course, but we don't own that standard.
So you own the intellectual property, but you don't charge royalties or licenses.
Maybe it's worth me just making it very clear what the difference between LoRa and LoRawan is.
Right.
LoRa is Semtech's IP, and it refers to the radio transmission, the physical layer. It's the way of making a signal get from the transmitter to the receiver.
Yep.
It's what happens on the airwaves. LoRawan is a protocol. It's what turns bits and bytes into communication.
Yep.
And allows people to connect, disconnect, and control the security and all that stuff. So LoRawan is owned by the Alliance, and LoRa, as the physical layer, the radio transmission, is the IP of Semtech and is controlled.
So can we move? Let's move on to the sort of applications. So let's suppose, what applications would an engineer want to use something like LoRa in? Start with you.
Well, I mentioned smart agriculture. There's other things like infrastructure monitoring, ones which are, outdoors, typically over wide areas. And there's a recent press announcement on the LoRa Alliance website about a German company who's doing quite a massive rollout of LoRa technology for energy and water utility monitoring for the infrastructure. And I'd say that's quite a good application, but there are many applications where people have tried to make LoRa work and it hasn't been the ideal fit. And there are good reasons for that. Where LoRa excels is energy consumption, so battery lifetime and cost. So it's quite a low-cost technology to implement. A node is quite low cost. But just to pick on one area of weakness, latency. If you have a message you want to get from a node to the server and then the server to respond, to acknowledge the message or to give an instruction to the node, that latency is quite important for a lot of applications and even ones you don't think are important. So perhaps the biggest IoT application in the real world at the moment is still smart metering. And smart metering, you think, oh, well, you're just sending an energy reading up to the cloud once every hour or twice a day or something like that. It doesn't need latency. But in fact, if you have a pay-as-you-go meter and you want to buy some energy, then you want to have that energy straight after you pay for it. You don't want to have to wait half an hour, 2 hours before your electricity turns back on again. So latency is very important for smart metering, and it's also important for a lot of smart city applications as well. I got here today on an e-bike, a line bike, and again, you have a device which has to be unlocked securely from a server remotely, and you don't want to be waiting around 10 minutes in the cold while some server responds to your request to unlock your bike. So latency is, as I say, one of the big challenges, and if you've got an application where latency is at all important, then I'm not sure LoRa is the right technology.
I think there's just a small clarification on that. But the way that most LoRaWAN things work is in a class A where the device wakes up whenever it wakes up. All the period it's asleep, you've got no way of contacting it, so it's literally asleep. When it wakes up, it pings a message, then the rules of the game are you've got a slot to downlink to it. So if you need to get a message, you can get a message quite quickly, within a second, down to the device after it's talked to you. So provided there's an initiation from the application, you've got relatively low latency. But if you want to just switch on the water sprinkler, you're going to have, if the device doesn't uplink until every 15 minutes, you've got on average 7 minutes to wait and up to 15 minutes. So if you want to command it to do something, then you're going to have to build in that idea of how often it wakes up. And so it's like you don't get anything for nothing. If it's going to burn so little power, it's asleep.
I think picking up on the smart meters, I think one question I would have is like that specific application. I kind of find is unnecessary in terms of, well, let's put it this way. If you've got a smart meter for a standard home, wouldn't it make more sense just to use the Wi-Fi? What would be the added advantage of using LoRa in that situation?
Well, I mean, smart metering is a real thing in the UK, and the smart meter companies decided, or the government in conjunction with them, decided to use cellular. So all your smart meters, electricity meters, got basically a cell phone in them.
Oh, is this because? Oh, I see what you're saying. You're saying that basically the network itself is not controlled by the home user, but it's controlled. But you're saying that basically, if smart meters were to use things like internal Wi-Fi, every user would have to program it, make sure that it was connected to their system, essentially.
Well, everybody would have to have Wi-Fi.
That's true.
And it would have to reach into the cupboard. And those are two potential issues.
Yeah.
And
So
there's a
more about
major
accessibility
security
as well.
issue there. They want to take control of all of the security layers there.
Yeah.
There's no way they're letting you step in there.
I see what you mean. So okay. Because basically, trusting the user to get it connected essentially leaves it potentially vulnerable. I see what you're saying. But that actually is interesting.
So
You go on.
LoRa as a technology started back in 2012, and our home turf is what we tend to call smart meters. And I think we said this earlier on. I call them connected meters because, to me, something that's smart needs to have smartness, not just connectivity. But that's the home turf of LoRa, not LoRawan. And literally millions and millions of smart connected meters around the world, gas meters, water meters that don't have any electricity in them, for example, are enabled by LoRa. And less so LoRawan, although that's across a lot of countries in Europe now where they've got nationwide networks. So it's not that you can't, you just got to bear in mind how the system works. But you can build any protocol you like on top of LoRa as a transmission medium. So you don't have to have latency.
To make it clear, LoRawan is the protocol. It's not the actual physical layer in the transmission.
So most of the connected meters in the world, and there's millions and millions every year, are not necessarily on LoRawan.
Right.
But they would be using LoRa just because of the penetration and the length.
So, Richard, that's actually drawn attention to one of the kind of compromises that I think the LoRa Alliance have made recently by introducing LoRawan, which is a big advance as far as kind of standardizing, making the LoRa technology more scalable and usable. You've actually reduced its flexibility a little bit by
anytime you bring in rules, cases. Then you have to play by the rules, and if the rules don't fit, you've got two choices: you walk or you play, right? So, and any vertical that's that big and metering across the country is huge. You can afford to develop your own protocol, put on your own security layers. You don't have to use an open standard. But we do have plenty of countries around the world who are using LoRawan in the metering space. You just got to understand what you're doing. And the other thing that, of course, you get with things like meters is massive amount of security and things like updating. Some countries absolutely say, this thing comes out of the factory with the firmware that's in it and thou shalt never change it. And other countries say, oh yeah, you can update it, but you're going to have a complete image. Every single byte has to be signed in the memory space and all kinds of different things that happen around the world. And our meters here, basically, they're stuck the way they're made.
Just before we move on to questions, just to wrap up, I've got one more question. Earlier on, you showed me on your phone about the LoRa system in operation, and specifically, you showed me that you had a temperature sensor. I think it was a temperature sensor, wasn't it? Thermometer.
Is that the tracker in my bag?
Yeah, that's right. Yeah, the one that was, and it had gone about 15 miles.
So I've got a tracker in my bag, and I don't know if you guys know the Helium network, but it's this crazy thing that's happening right now. There's about 3,000 gateways every day being installed on the Helium network. And so we just looked at the tracker from my bag, and we're hitting 170 gateways from here. And some of them was Potter's Bar, and there was Isha.
Yeah, 15 miles away.
So if anyone wants to see that, I can show it to you on my phone. So there's no question about it. As a technology, it reaches far.
Yes, definitely.
But IoT's not a technology game, right? The technology has to be good enough to get in the game. There's like a table stakes. Does the technology have the right kind of structure? Beyond that, it's about, does the business model fit what you want to do? Do you want to buy connectivity, build connectivity, rent it, share it, crowd it, whatever? about the business model has to fit the application to get the ROI you're looking for. And where we are now, there's enough technologies. We don't need any more technologies, and we don't need to argue about which technology is better. We just have to say, yeah, you're better off using NB-IoT for that, or you're better off using LoRa, and just make the business model fit. And that's part of this maze of complexity that I talked about. And our biggest challenge as a group is to navigate through the maze of complexity to reach what we actually need, which is a solution. And one more point on technologies is I divide the IoT world into two types of people. There's the technologists, and they live in the world of maths and physics. They understand that if I do this, I can tell you how far, how cold, how hot, the vibration, whatever. They answer a singular question. The application guys, and I call them the application innovators, they say, I want to make my cow healthier. They don't know what to sense, they don't know how to sense it, and they don't know what technologies they need. But one thing's for sure is one technology ain't going to cut it. There's a mixture, there's a recipe, and the technologists bring ingredients, and that's part of that complexity, is that we have to build a recipe that makes a solution, and that, if I'm looking at something I'm deeply involved in right now, is flood prediction and prevention. We have software hydrographical models of water runoff. We have LoRa sensors measuring water level. We have the internet bringing weather forecasts. We have high-resolution cameras spotting debris on culverts. So it's not one technology. It's a mix of technology plus analytics, and you can tell if it's going to flood in the next 6 hours, 12 hours, 24 hours.
But then I was going to say, though, because of the range, do you not feel like that it could be potentially more vulnerable to attack in terms of long range? Because anyone can attack any system. That goes without saying. Wi-Fi, Bluetooth, whatever, right? But usually, because the range is limited, you have to get within a certain distance. But now, if you've got a system where you can go 15 miles, does that not leave gateways potentially exposed because of the fact that they can be communicated for such a big distance?
I don't think it necessarily does. I think there are definitely security questions to be answered by the LoRa Alliance, and some of them are answered recently by Lorawan 1.1, I think, was a recent release which improved security. But that's separate from the distance thing. Yeah, and it's too big a topic to talk about at this forum.
Fair enough.
But I'd like to hear some questions from the audience.
Absolutely,
if that's all
right, fantastic. So we'll move to the audience. Any questions? Can't see. Go on, don't be shy. Let's get one. Oh, I don't think we have any questions.
Wow, I scheduled
No? Oh,
off.
we got one.
Oh,
There
some.
we go. Finally, brilliant.
I'm a relative newcomer to LoRa, but the
could
subject.
Get close to the mic.
Sorry,
That's perfect, thank you.
I'm a relative newcomer to LoRa, but I just wanted to know: did we discuss the latest advancements in LoRa technology? I wasn't sure if we got to that subject or not yet.
Good point. I think one of those was about the fact that you made it open.
So I guess, number one is that there's now, the Lorawan is now an ITU standard, so it's officially a standard, not a de facto club that we all created. From the technology that Semtech's bringing, there's something that we call GPS offloading, where essentially if you take our latest silicon, it's got built into the same, the one piece of silicon, your LoRa transceiver. It's got a full modem for that with the management of the device, but it's also got a Wi-Fi sniffing and a GNSS satellite sniffing. So if anyone knows how GNSS systems work, essentially you receive time beacons from satellites. Then you also receive from them a very accurate representation of their location in the sky. And that ephemeris data, that comes down, takes a long time to receive. So anytime you wake up, and let's say you've got a device, it just wants a location, then LoRa devices want to be asleep. They wake up, they want to be done. They don't want to have 2 minutes or 3 minutes to lock onto half a dozen satellites. So if you wake up, and in a few hundred milliseconds, you can get the pseudo ranges from the different satellites, we can uplink that and fix in the cloud. This is a major push forward for power consumption for satellite positioning-based devices, because we can now make the choice on a device to say, are we looking for an approximate location? Is our device going coast to coast on the US? We don't care about 50 meters. We just want a rough fix. We're going to get 4 or 5 satellites, is going to be plenty. Or do we care whether it's this side of the fence in the port or this side, because this side's the active port and it costs 10 times as much to have your container there than it does over here, in which case we might want 15 satellites. So we can control the power consumption. So that's a great development in terms of how you get the tracking. The ability to add Wi-Fi on top of that is really good for indoors, outdoors. You know, we can fingerprint buildings with their Wi-Fi coverage. Hospitals have got thousands of access points, hotels, warehouses, those kind of things. So some of those things are really important and moving us forwards. The other thing that we've seen a lot of problem with or a lot of comments on is that devices in the wild are kind of out there until they need updating, then you've got to go visit them. So things like firmware update over the air. When you've got a very uplink-centric protocol, firmware updates over the air is hard. And it's really taken a lot of effort to come to consensus over how that's really going to work. And that's pretty much there now. And you can, in most cases, you know, it's best to deal with very small patches, so more like firmware patching over the air. But you know, we can do that, and we're starting to see networks actually deploy that. Do you want to say anything about any of the other new parts in the standard?
Yeah, well, I did mention security, which I think is a big, important topic. It's when LoRa started out, it was kind of an afterthought on a lot of IoT type applications, but now it's absolutely foundation for anything that you want to put, you know, on the internet. So yeah, I think it's been improved to a level which is now probably good enough for a lot of the applications LoRa is involved in. But there are some applications like smart metering where I don't think it would pass the test, to be honest, as far as security, and in some markets, like the UK, for example. Security has improved as far as I can see, but I'm not a LoRa expert either. I'm an applications expert. I know about a lot of different technologies and why some are good for some applications and some aren't.
Right.
So yeah, Richard's the best guy to talk about the new stuff.
Right. One more question. Anyone? We're on the row at the back.
Hi, I'm Mahesh from LeakSpotter, Boston. So my question is this: I know that there are 2 or 3 different kinds of LoRa.
Sorry.
Sorry.
It's a bit louder. Yeah, it's a bit hard to hear.
Okay. So I believe there are 2 or 3 different kinds of LoRa levels A, B, and C for battery consumption. My question is: we have a device that's supposed to last 5 years on the battery, so SIP power. Should we just send out a signal once and then wait for feedback as an acknowledgement, or just send it out like 3 times and hope to God something gets through? What would be a better strategy for saving battery power?
What you're saying is that to send a signal out to the devices that the individual devices to have them come to call back. Is that correct?
Well, yeah. So if I send out, so our devices send out data once an hour or so.
Yeah.
So should I just send something out and wait for acknowledgement, which I believe is category A, or should I just send it out like 2 or 3 times and not worry about getting back an acknowledgement and just hope it works?
I think it depends
so,
on
so
application.
there's a couple of options there. Class A is the rules are you transmit, you have to listen. You can transmit whenever you like, but you have to listen. You have to listen 2 times. Once on the channel you transmitted on, and once on a special downlink channel. So there's 2 opportunities for the network to get back to you. And that's as simple as Class A is. Class B is they beacon from the network to basically allow all the devices to become time slotted. And then a device can wake up and listen every 2 seconds or 4 seconds or 16 seconds, whatever. And then when the device is going to wake up, and you dispatch a downlink, and the network will dispatch it as and when it knows the device will be awake. So that's class B. Class C is really much more for things that are plugged in, where the device has got its receiver open all the time. We really see very little class C devices. It's in there for, as completeness, and it gives you the option, if you do have, a USB power supply or something, then you get very, very low latency in downlinks. But in terms of getting your confirmed message across, that's not really a class thing. That's really an acknowledged message thing. In that you can do that on class A, you still get your 10, 15, 20 years, whatever, on your battery. You just decide how often you're going to want to confirm the message. And there's something called adaptive data rate, which is where we try and make sure that devices that are close to gateways don't spend time on air that are going to block weaker devices from further away. So the network typically says, you're banging in, can you transmit faster, twice as fast, 4 times, 8 times as fast, so you spend less time on air and you've got less time to be in collision. So the network is expected to downlink from time to time. And a lot of devices say, I'm getting that downlink, I'm going to assume my uplinks are good because I'm getting the downlink. And it becomes not a rule, it's down to an application decision.
Would you like to have the final word before we wrap up? Yep.
Not on that subject.
No, fantastic. Right, thank you ever so much, guys, for being here today. Please give my guys a round of applause. And that is it. Thank you very much.